In today's video, I'm going to be disassembling a faulty Keurig coffee maker. It's probably the most popular or one of the most popular brands being sold today. A very common problem with this type of a coffee maker is over time the flow becomes very slow and it takes a very long time to fill up a cup. The coffee maker that you see right here is very similar to the one that I'm going to be disassembling. A friend of mine gave me another one of these that was faulty, and I did not need two, but I do know there are some really good parts inside this coffee maker which I can salvage and use for other projects. When I disassemble the coffee maker, I'm going to be testing a lot of the parts inside to see if I can discover why the flow is restricted. By doing that, if you have a coffee maker like you see here, you will then be able to fix yours if you experience the same problem. Now keep in mind, if you're having a problem where you do have restricted flow or it takes a very long time for the liquid to come out to fill up the cup, the first thing you want to do is take out this cup right here. Push this to the side. Now inside the cup there's a needle. You got to make sure that that needle's clear. This one has a cup connected to the bottom. Take your thumb, push that way as you lift up like that. Turn it around. Once that's off, blow through here with your mouth. Make sure it's clear. If it's not clear, you're going to take a paper clip and go in there and make sure it goes through into where the point pierces the bottom of the coffee. You can see it sticking out right there. Make sure that's clear. If it is, then you know that this is not the problem why the coffee is coming out slowly. In order to disassemble the coffee maker, first thing you're going to do, remove the side. You can also lift off the plate on the bottom. Remove that. I'm going to lay the coffee maker on its side, give you a better camera angle so you can see the screws that must be removed. Now your coffee maker may vary slightly with the number of screws on this bottom cover, but you're going to have to remove each and every one of the Phillips screws that you see on the bottom plate. Let me remove those and then I'll show you the next step. Once all the screws have been removed, the plate will easily pop off. If it doesn't, it's because there's little plastic tips that are hanging over the metal here. You're going to have to get the plate, lift it up on this end, and slide it that way. So I'm going to grab here, pull outward, and slide back, and then the cover's off. You can see there's ground wires connected. Leave those alone, don't touch them. The next thing we're going to be doing is you're going to be removing the screws that hold this plastic ring on the bottom of the coffee maker. From this angle, it will be a lot easier to point out the screws. You're going to need to remove the Phillips screw here, the one at the bottom. There's one right inside here, behind the silicone line. And there's one more over here in the corner. I'm going to remove those and then we'll go on to the next step. After the screws have been removed from the plastic ring, the next step is to take a pair of pliers. You're going to squeeze the clamp together. You're going to slide this off the end, take the silicone boot off the pump, and pull it off completely. Once that's off, you'll be able to slide this whole piece downward. It'll come off the bottom of the coffee maker, and you could take the wire here, remove it from this loop. This is a cord restraining loop. Remove that. Now you can see this has been removed off of the front center of the pump over here. This is where the water reservoir sends the water into the pump. Now this red and white wire, we're going to have to undo these two screws so this whole piece can come out as well. Lay that down. All that wire goes to is a little tiny LED. With this off, you can now lift this up and you can take the wire, feed it through the opening so you can pull the plastic ring off. But before you do that, you're going to have to drill out the rivet that holds these ground wires. take a drill, like a 3/16 or a 1/4 inch drill, drill out that rivet, and then when you do, each one of these ground wires has a ring connector on it. All 3 will come off. When you go to put everything back together, you place the 3 ring connectors all together on this side of the plate. Take a very tiny screw, use a stainless steel screw, push it through the other side, this way, put the head that way, and put a washer and a nut on this side and tighten it down. Now I'm going to show you the one hidden screw that must be removed in order for this entire plastic shroud to be able to slide down and off the entire system. You're going to need a very long screwdriver, Phillips, like you see here. Number 1 should work fine, or you could use a number 2 Phillips like you see here. Just make sure it's long enough to go all the way up the cover. The screw is located on the right side of the machine when it faces you, so your coffee would be sitting right here. So the right side is where the screw is going to be. Let me rotate the coffee maker into position so I can point out where the screw is. Alright, I'm holding my phone so you can see in there with the light. If you look all the way into the back, you should see the Phillips head screw shining. Once that Phillips screw has been removed using the very long Phillips screwdriver, you can then hold this cover with your left hand as you take your right hand and push on the bottom of the unit. You're going to be pushing on the pump assembly and the plastic housing inside. As you push, you're going to see the seam right here open up. Once the seam opens up, it's going to open up, but when it gets to this point, it's going to try and hang up. And the reason why it's hanging up in this one little spot here is because when you come around this corner, right around here, about 1 inch. So from this corner, you come around 1 inch, and there is going to be a plastic clip. Now the only way you're going to release that clip is by spreading this open as wide as you can. Then you're going to come in at an angle using a small screwdriver, insert it there, and you're going to slide it all the way in, and you're going to try and push the back of the clip. Now the way the clip is, it hooks that way. It doesn't hook this way. So because it hooks this way, you have to push on it from this side and let it go that way to unhook it. Once that's released, you're going to come around the side. Alright, and you're going to find another clip. And that other clip is going to be located right on this curve. It's about 4.5 inches away from that one. And when you get here, you're going to have to do the exact same thing. Insert a very small screwdriver, push on the inside of the clip towards the outside of the cover. So you're going to go from the inside, pushing outward to unhook it. Once you unhook it, you're good to go. The whole unit will slide out of this plastic housing. You're now looking at the other coffee maker. This is the one that's faulty. It has the restricted flow. I already removed the cover from this one, but here you can see the actual clip. And this is what I want to show you right over here. You see the way it's hooked? It hooks going inward. So you don't want to be pushing this way, because if you start pushing this way, you're only going to make it lock further. So you want to go in from the space that's going to open, just like this, all the way in, and go behind it and push. The other clip, I'm going to show you the spot on this one. I didn't care about being careful because I wasn't going to be putting the coffee maker back together, so I just smashed it with a hammer. Let me show you that one. This is the good one. So this is the good one. And right over here, you can see where I broke it off. It's right on the curve. So do the same thing. Come in like this and get behind it and push. And you should be able to pop it off without any problem. This is usually the biggest problem people have, is opening up the Keurigs to access everything on the inside. Now I'm going to begin the process of pulling apart this unit. I'll take all the solenoids out. This is a reed switch, the motors, everything. and I'll show you how you could test them. And along the way I'm going to look if I see any areas that appear to be blocked. Like this area here, a little bit of a buildup in it. We'll take a look at that. So this right here, this is off of the pump inlet. Keep that. These are excellent hoses. All these elbows, all these tubes are made out of silicone, so they're high temperature rated, so this will definitely come in extremely useful for other projects. The reed switch, what that does, that senses the water level inside the tank. If you look right here, there's a disc inside this tank, alright? And it moves back and forth, and it just so happens to be magnetic. When the disc is too low because of a lack of water, what will happen, it'll fall away from the sensor and it will turn off the system because there's no more water. Let me remove everything that you see here, the reed switch, all the silicone tubes, these solenoid valves, this pump. Let me get them all out. Then I'm going to turn the unit over, make sure there's nothing else on that side to remove. Then I'm going to take the pump out of the bottom. When everything is out, I'm going to inspect everything and show you how to test each part. Okay, I'm almost finished cannibalizing the unit. The circuit board was mounted right here. I took that out. We'll look at that in a minute. Over here is a step-down transformer from 120 volts down to 12. Actually 14.5 at almost a half of an amp. So this will be coming out too. Very good to have. I have the pump still to take out and the heating unit. When I get to the heating unit, I'll show you how I take that out. In order to remove the cover from on top of the coffee maker, after the handle has been removed, you're going to locate the two Phillips screws, one hole here and one over there. Just reach under with the Phillips screwdriver, unscrew it. When it's unscrewed, the whole cover will just lift up and pull away. One more thing I wanted to show you. After you remove this cover here, you can then remove this entire top cover that wraps around. There's a screw right here and one on the opposite side. Once you remove those, the whole piece will lift off. To remove the heater, everywhere where there's a washer, so remove this screw here, that one I already removed, you're going to remove that one and the one back there. Once you remove the screws on top of the heater, you're going to remove a screw there, over here, and there's going to be one down in here and one in there as well. Take all four of those out and this whole thing will separate and you can remove the heater. Okay, let's take a look at everything that was pulled from the unit. This is where the water entered, all the silicone lines. Got all those. Now over here, I thought this was actually a one-way valve, a check valve. It turns out that there's a very fine mesh screen inside this. So all you have to do is hold your finger over that one and blow through this side or that side and make sure the flow goes through nice and easily. If it's very hard to blow through, more than likely the screen is plugged up. This line over here has a check valve on it, so when you blow from this end, the air should flow through, and when you blow from this end, there should be nothing flowing through that valve. Everything you're looking at so far checked out okay. Over here is just a coupler, nothing special. A whole bunch of these lines. These are really good lines, so I'm glad I got these. This is the part on top. When you push the handle down, that pierces the coffee. Let me move all this out of the way and show you some other stuff now. Here's the control board. There isn't too much you could do with this. I'm going to salvage a few parts. Over here you have an optocoupler, 6-pin and a 4-pin optocoupler that isolates a lower voltage from the higher voltage. And this might be a triac. I haven't looked too closely yet. But that is really about all that I would salvage from this board. I have an inductor over here I might grab, and maybe this capacitor, but that's about it. Over here is another board located by the panel on top where you would push the buttons. And this right here looks like some sort of a pressure switch, because you notice the line goes into the back of that switch. So this will be interesting for me to play around with. The LEDs, I'll just desolder those, save them, as well as the little push buttons. They're working good, so I'll keep those too. Transformer, this is the one I took out earlier. And it says input, which is the primary, are the two red wires, 120 volts, and the output, which is the blue, secondary, 14.5 at almost a half of an amp. This is a very good transformer. I'm glad I got that one. Now to test these is very simple. You could just apply 120 volts to these two red wires and make sure the output is around 14.5 to 20 volts AC. When you do check this, it'll probably be around 23, 24 volts, no load, and that's normal. If you do have power to the coffee maker, the display works, then more than likely the transformer is just fine. A few other goodies here. That's a pretty good spring. That's a smooth steel pin. That was on the pivot point of the whole top assembly where you push the handle down. And I got these T's. These will come in very handy for something. Over here is the reed switch, and that senses the water level in the tank. What I'm going to do is connect this up to my digital meter right here, alright? And it's set on a continuity setting. Let me turn it on. When you touch the two together, the alarm goes on. Push this off to the side. You don't have to see it as long as you can hear it. So let me take each one of these, connect it up. Let me bring the lid very close to this, and the alarm should come on. Here we go. Perfecto. You know that switch is working just fine. 0 ohms, and the alarm is sounding. Let's take this away. Over here is a little pump that was mounted inside the unit. It says 12 volts mini pump. When you power this up, if it's working properly by applying 12 volts, positive to the red, negative to the black, you should feel pressure coming out. Let me apply 12 volts. And it sounds like a pump. Yep. Working perfectly. Can rule that out as a problem of the unit. Over here, this right here, it says main terminal 1, so clearly this is a triac, and more than likely this was handling the flow of current into the heating elements on the heating unit. Over here is where the power went into the unit through this board. It's like a filter board. You have these toroids with a copper wire wrapped around it. This is definitely a power supply board for filtering. And there's really nothing to go wrong on this board. That's an MOV. If there's any high voltage spikes on the AC line, when these go bad, usually they'll blow apart and turn black. The capacitor's not swelling, so everything else looks good, and more than likely, there was nothing wrong with this board. Now we're down to just 3 things: the pump for the unit, 2 solenoids, and the heating unit. Let's take a look at this. There's 2 of these. This is a solenoid valve. When you blow through this right here, let me get a tube, you should hear absolutely nothing coming out of that end unless 12 volts DC is applied to these wires. So let me do this. I'm now going to blow into it, and nothing. So now, let me connect up actually 13.5 volts, right? And it doesn't make a difference which way it goes on this. Just heard that click. Now let me blow through it. And that works perfecto. This was not a problem. Now let's take a look at the other solenoid valve. Alright, when I connect this up, blow through it, nothing. And if I apply power, it should open up. I'm not even hearing anything here. Doesn't sound good. Nope, that's not working. And guess what? You can reverse them, it doesn't make a difference. Nothing. This is faulty. That explains why the water was barely coming out of the machine and it took a very long time for it to fill up. So if you're having a problem with your unit, it's a very good idea to check out these solenoid valves, and they are very easy to get to. As you saw earlier, once the bottom plate is removed and you slide that plastic cover off the whole unit, these will be right on the side of the unit. Apply 12 volts to the blade connectors and make sure the air can flow through. Over here now is the pump for the whole unit. The suction is in the center, along with this little one on the side, and the discharge is right here. Let's hook up the hose and put it into a container and see how it goes. Okay, let's put this bowl right here. I'm going to take the outlet, put it right in here. Let me keep this down. Keep it down just like that. Over here is going to go into a cup of water. Put a cup of water right over here. Let's take the elbow. Put that in there. Alright, what I'm going to do now is keep that under the liquid. Hold my finger over this one, because it's going to want to suck through there too. And let's see if the water flows through. Here we go. Wow. That worked extremely well until I sucked some air and then it stopped. So this pump works fine. And I got a very nice heavy-duty power cord out of it. And the last thing I'm going to show you is the heating unit. Really a cool unit. In the very bottom, I guess you can see it there. You see the spiral, the coil? Winds around, your heating element is right there. It spirals around the bottom. Over here is a temperature sensor. We should be able to measure the resistance of this. Let me separate this. Let's see if it's a thermistor. To test the thermistor, I'm going to use the 200K setting on my meter for resistance and just check between these two. Around 41K. So if you were to heat this up or make it colder, that value should change as you're looking at the meter. To see if the element's good, you could measure the resistance between the two, and it should be around 10 ohms. So let me put this at the 200. This is on the 200 ohm setting. Let me check between here and here. 10.4, 10.5. It's also a good idea to put some water inside this unit. Keep it vertical, turn it this way, and you're going to measure on a high ohms range of around 2 million or more. You're going to test between each terminal and the housing of the heater. Nothing should happen if there's water inside that heater. If this does register a reading, That's going to indicate a faulty element, and you're going to need to replace the entire heating unit. Let's take a look over here now. So we know this is a temperature sensor. Goes to the control board, the heating element. Over here is a thermal switch. When the unit is cold, this should give you continuity, meaning current should be flowing between this terminal and that terminal. Once again, meter set to the continuity setting. Let me lay it right there. You check between both terminals, and that's perfect. If this is open and this doesn't make a buzzing sound and there's no reading, that's going to indicate a faulty thermal switch. If the thermal switch is faulty, more than likely, in here you have a thermal fuse. If the thermal fuse did open up the circuit, more than likely that is because the thermal switch itself failed. The heat inside this canister got way too hot, the thermal fuse blew, it opened up the circuit, preventing further heating. This is just a security feature in the event that the switch fails. Now to test this, once again, put the meter on a continuity setting, touch this together, and you want to measure between the terminal where the fuse connects, which is this side, and the other end where this wire goes. Now in that case, it's going over to here, to this black wire, and I'm going to touch here. Current is flowing through the fuse, indicating the fuse is good. Let's take a look at the top of the heater. Top of the heater has a few different probes. If you look inside of it, you can see them sticking out. There's a real short one over there. Then you have a real long one in the back behind it, and a medium-sized one there. Those probes are for detecting the level of the water inside the unit. And that's it. I hope you enjoyed this video. If you did, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlist as well. Thank you very much for watching.